Hello friends, welcome back to the class of thermodynamics. In today's session of thermodynamics, we will see about the temperature scale. What is the temperature scale? Okay. So for this, we will use the concept of thermal efficiency. We know thermal efficiency is nothing but W net by Q1. Now W net we can write in terms of heat transfer Q1 minus Q2 divided by Q1. When you will simplify this, you will get 1 minus Q2 by Q1. This already we have seen. Now, in the case of reversible process or maximum efficiency, you can say if the process is reversible, the efficiency will be maximum. So, in terms for the case of reversible process, how you will represent efficiency? We represent efficiency in terms of temperature. So here it is written as 1 minus T2 by T1. Correct? So for reversible process, efficiency is function of T1 and T2. So in place of 1 minus Q2 by Q1, you can write 1 minus T2 by T1. From this, we will get a good relationship. How? Just now see. Same thing we have written 1 minus Q2 by Q1 is function of T1 and T2. Or if you will remove this, you can write Q1 by Q2 is function of T1 and T2. Correct? Now, as I told you, efficiency can be written in the case of reversible processes 1 minus T2 by T1. So, from there you will get Q1 by Q2 is nothing but equals to T1 by T2. This is the temperature, thermodynamic temperature scale. I mean this thing only from the thermodynamic temperature scale. Temperature can be represented in terms of heat or heat can be represented in terms of temperature for the case of maximum efficiency or reversible efficiency. So Q1 by Q2 equals to T1 by T2. Okay, this is your thermodynamics temperature scale. Very small concept, very easy thing to remember. Now based on this, there is one question problem. Numbers are not there. This is a derivation type. See the problem carefully. A reversible engine operates between temperature T1 and T, where T1 is greater than T. The energy rejects from the engine is received by second reversible engine. So there are two engines. Energy rejected from this engine is received by second reversible engine at the same temperature. Temperature is same. The second engine rejects energy at temperature T2. Now here T is greater than T2. So till now you have seen three temperatures T1, T and T2. What is the relationship from this? You can observe the relationship. T1 is the highest, correct? Then comes T again, then comes T2. Am I correct? So you are getting this kind of relationship from these comments, or you can say statement. Now you have to show temperature T is the arithmetic mean of temperature T1 and T2. What do you understand by arithmetic mean? You have read in the mathematics. Average of these. T is the average of these. When if engine produces same amount of work output, means when the both engines produce same amount of work done, the temperature T is the arithmetic mean of T1 and T2. You have to show this thing. Next, temperature T is geometric mean. Now what is geometric mean? Root over of T1 T2. T is equals to root over T1 and T2 when both the engines have same efficiency. So there are two important conclusions you can use directly for solving the numericals. If in the question it is given same work output, then you can write T is arithmetic mean of T1 and T2. Next, if it is given same cycle efficiency, then you can say T is geometric mean of temperature T1 and T2. This you have to prove. Now, how to prove? This is a diagram. Engine 1 is operating between T1 and T and doing some amount of work. Engine 2 is working between T and T2, doing some amount of work. Something is said here in the question. So from question you should be understand how to draw the diagram. Then only you will solve the problem correctly. Now, if they produce same amount of work, if they produce same amount of work, means W1 is equals to W2. So what is the W? How you can write W in terms of efficiency? How? Efficiency is nothing but W by Q. W by Q, correct? Now for first engine, work will be eta 1 into Q1. Q1 is the heated rate, eta 1 into Q1. For the second engine, eta 2 into Q2. Q2 is the heated rate in the second case. Okay? So eta 1 into Q1 equals to eta 2 into Q2. What is eta? 1 minus T by T1. 1 minus T by T1 for the first engine. For the second engine, 1 minus T2 by T. 1 minus T2 by T. Correct? Now, relationship between Q1 and Q2. Relationship between Q1 and Q2. What is the relationship? Q1 by T1, Q1 by, this is from temperature scale. Q1 by T1, this is equals to Q2 by T. Q2 by T. Q1 by T1, this one will be equals to Q2 by T. Same thing written here. Now, from here you will get Q1 is how much? Q1 is T1 by T into Q2. Q1 is how much? T1 by T into Q2. Same thing we have kept here. Same thing we have kept here. Okay? And this is already there. Now, when you will solve, what will happen? When you will solve it, what will happen? After simplifying, you will get this thing. No, this is this. Here it has told how you got this thing. Okay? Now, coming to next. When you simplify this, what you will get? When you simplify, what you will get? See, you will get T1 by T minus 1. How? This Q2 will cancel. Now T1 by T multiply here with 1. You will get T1 by T. Next, multiply this with this. So this will cancel. This T will cancel. So it will be 1. You will get T1 by T minus 1. Correct? And here 1 minus T2 by T. So when you will solve this, you will get T equals to T1 plus T2 by 2. Means T is the arithmetic mean of T1 and T2. You have proved the first case for the same amount of work. Now for second case, what is given? Efficiency is same. Efficiency is nothing but 1 minus T by T1 for the first engine. For the second engine, 1 minus T2 by T. This is same. Now simplify this, 1 will cancel, minus will cancel. You will get T square equals to T1 into T2. You will get T square equals to T1 into T2. So T will be root over T1 T2, correct? So this is the second statement or second proof you have to prove. For the same efficiency, T is a geometric mean of T1 and T2. Same thing we have proved. So this is how you can solve the problem by using the concept of temperature scale. Okay, thank you for today's session. I hope this is useful for you. We will meet you in the next section. Till then, goodbye, take care.